Hey, how's it going, folks? It's Hellbent, and welcome back to the last episode in the Making a Snake game in AutoHotkey. Where we left off is we had just finished creating it so that way our snake is able to move and update the map with its position. But currently it doesn't have a way of changing direction if it gets blocked by something. So if we come in here, open up the game, let's go ahead and change the dimensions of the game. Actually, that's not the right one. Let's go in here and change the dimensions of the game. So if I come up here to the top where we have our global variables, we have window, and it has a width and a height. I'm going to change it down to a little bit smaller because soon we're going to be checking out if our snake gets stuck, and we want to have a smaller window for that. So I'm going to change it down to about 300 pixels for its width by its height I'll do about 200 pixels. So 300 by 200, very small window. And here we go. And if we press number pad 1, we add a new snake, and if it has a valid direction that it can move in, it'll move until it encounters either the wall or another snake. And for some reason I have a issue with something. We'll check that out in a second. But anyways, let's go ahead and create make it so that way now our snake can change directions. So the setting a new direction method is going to tackle three different things. One, it's going to set a new direction for the snake if the snake has been traveling along the same path for too long, which we have set as this dot changer, and if it equals a variable called change at. So if we have this variable called change at, that's a number between x and y, or 10 and 20, 30 and 40, whatever. And if each time we run through this, if our changer counter equals that, then we automatically set a new direction. If not, it's going to try to move in its currently selected direction. If it can, nothing happens, it just moves. If it can't move in that direction, it'll automatically call that set new direction. So we have two ways of getting into the set new direction, and then the set new direction is going to do three things. One thing, like I said, one thing, it's going to set a new direction. The other thing that it's going to do is it's going to determine whether our snake is stuck or not. So each time our snake changes directions, it's going to add to this dot stuck. Once this dot stuck reaches a certain threshold, it knows that it's stuck. So to reset that, to make it so that way our snake doesn't get stuck all the time, or that it thinks it's stuck all the time, each time a snake has a direction and it is actually able to move in that direction. So if our snake is told to move up and it can move up, it's going to go ahead and move up, and it's going to reset the value of stuck to being 0. So that way it has to get stuck for 15 more turns before it's actually stuck. The last thing it's going to do is our set new direction is also going to determine if our snake can grow or not. So our snake is set up so that way when it calls up a grow method, it has to win a lottery to determine whether it's going to get a new segment. Well, the thing that determines whether it's going to get to have the chance to play the lottery is in our set new direction, which will be a random value between some number and some other number. And if the snake changes directions a certain amount of times, that's going to equal it, which means it gets the chance to grow. Let's just go ahead and type this out. So the first thing we're going to do is in our move snakes, what we're doing is we're looking to see if this variable here, this dot changer, each time we run through this, we add 1 to it, and we check to see if it equals the threshold that we're looking for. So the first thing we're going to do is in our set new direction is we're going to reset our counter back to 0. The next thing we're going to do is we're going to get a new random value to determine how many moves the snake can take before it automatically has to set a new direction. So I'm going to create a random number. and I'm going to call it temp variable. And I'm going to set it how many times do I want the snake to move before it automatically has to change. I'm going to give it a value of, let's say, 3 to 30. So it can move anywhere between 3 and 30 times before it automatically has to change directions. So maybe sometimes it'll only move 3 times and then change directions. Other times it might be 30, depending on whether it hits an obstacle or not, because that automatically triggers this. Then I'm going to say that this dot change at, which is the variable that's storing this, so that way we're testing to see if this dot changer, when we add to it each turn, if it equals this. And this change at is equal to temp variable, which is our random number that we got. So in our move snakes, we're adding 1 to the changer, and then we're testing to see if it equals our change at. So let's say that change at, when we got our random number, was 10. So this dot changer is 0. Then the next time it's 1, then it's 2, then it's 3, then it's 4. Then eventually it gets to 10. That becomes true, sets new direction. This gets a new value for a change at. This gets reset to 0, and it loops through again. Next thing, like I said, this is also going to set a new direction for a snake. So what I'll do is I'll create a new random number, and I'll reuse that same one because we're done with it. So I'll use that temp variable, and this time it's our direction. So we have 4 directions. Up is 1, right is 2, down is 3, left is 4. So we'll set our range between 1 and 4, and we will say that this dot direction is equal to whatever we got in our temp variable. Because I said that our snake, each time it changes direction, this is going to be how we determine whether our snake is stuck. So if it changes directions too often, it's going to trigger our reverse snake. So what we're going to do is we're going to take this dot stuck, the variable that determines whether we're stuck or not, and we're going to add 1 to it. And the last thing I said the snake does is it determines whether we're going to be growing or not. So we're going to say if this dot growing is equal to this dot next grow, I think. In our constructor, we had created this dot ng, and we set it initially to be between 10 and 50. So it has to change directions between 10 and 50 times before it can grow the first time. So this dot ng, which is set new direction, this dot ng. So if our, and this is plus plus. So each time we change directions, it adds to growing, this dot growing. And if it finally equals the value for the time that it's supposed to grow the next time, it's going to get the chance to win the lottery. But before we have it play the lottery, what we'll do is we will reset the value for the next time it can grow. No, let's put it through a random number. Random, we'll call it ng. Actually, I'll just reuse that same temporary variable, tv. And tv, how many times do we want our snake to change directions before it gets a chance to grow? Let's say between 10 and 40. 10 and 40. Then we'll set that as the next growth time, ng. And now what we'll do is we'll send our snake to the grow method. This snake, go to grow. And in the grow is where we play the lottery to see whether it can grow or not. Last thing I'll do is I will reset this growing variable back to 0, so that way our counter is reset. And I think that's it. I think that's it for our growing. So let's go ahead and run this, and hopefully everything works properly. I don't know what's going on with that. That's something I'm not really sure. Something's wrong with the way we're adding. We weren't having that issue last time, so I don't know. Did I type some? I don't think I was playing around with anything while we were away. But let me see. I might have played with something. I don't think I did. Wait, we're in tutorial. I should have made a copy. Damn. Usually I make a copy for each tutorial and then just update it. But we have a problem somewhere that our snake, it's adding that first segment off screen. And I don't think it was doing that last time. Actually, I'm positive it wasn't doing that last time. This dot grow. It's got to be in our grow method. What I'm going to do, I'm going to turn off the snake's ability to move for a second. So that way we only get the snake spawning in. So that's working. Let me put it back through the move again. And we get that one yellow square up in the... And okay, so all of our segments are getting put up there. Why are they getting put up there? Let me comment out the change direction. Let me comment out this. Okay. So it looks like if it's moving down or if it's moving... If it's update snake, this stuck, this dot map, okay, zero it out. This dot map array, zero it out. This dot snake, a index, new value, yes. I equals the length of our snake. Yes. Loop through the length of our snake. If I does not equal 1, then... Oh, okay, I see a problem. So, in our... when we're looping through and changing the snake's position, so let's say if we told it to move up, this is where it's actually going to change its position within its array. So it tells it, so its head is in grid space Y1, X2, etc., etc. But in here, I'm saying that this snake, this is going to be its new position, and I want it to be mine. This is where we're changing the segment of the snake to be where, so we have a snake, and it's comprised of these body segments. When we move our snake, we take the tail of the snake, and we get the value from the segment that was in front of it and replace it with that. So this cell is now in this cell. This cell is now in this cell. This cell is now in this cell, and this cell goes up if its direction was up. but we're not saying X and Y here. Dot Y dot X. I wonder why. I wonder if it was doing that in the last video too, but I didn't notice. But anyways, this dot direction. Okay, I think that should have fixed our problem, hopefully. Okay, so there we go. So now what I'm going to do is re-enable our change new direction, or set new direction. And hopefully our snakes start moving around. Okay, there we go. And I can manually, because we've set it up with a hotkey number pad 2, I can manually make our snake grow. And we'll see what happens when our snake gets stuck. I'll add another snake. So let's see. Here, let me reset this. Let me reset this. We'll add a couple of snakes, and we'll make sure that occasionally they grow. So I'll add 2 snakes. Let's see if they grow after a little while. Okay, that one got, yeah, they're growing. And we'll speed that up a bit. We'll say in the NG, after they grow the first time, I'll set it to a value of 5 to 10. So they only have to turn 5 to 10 times before they get their next chance to win the lottery. And I'll add a couple more snakes. And now that we know that's working, what I'm going to do is I'm going to let them see what happens when they get stuck. Sooner or later, they're going to get so long that they're going to get stuck. Okay, those 2 got stuck at the bottom corner. The 2 green snakes got stuck. That blue one shouldn't be stuck. I don't know why it's saying that it's stuck, but okay. Yeah, I don't know why that blue one shouldn't be stuck. Like, it should have changed directions by now, but apparently there's a cell that we're not seeing right there. Something's not getting drawn properly, maybe. But we'll have a look at that in a minute. So let's go now and deal with what happens if they actually do get stuck. And what happens if they get stuck is that they're going to change directions. To do that, what we need to do is, the first thing we're going to do is we're going to create another we're going to copy the snake's array. So the snake's array keeps track of where the snake is and how many body segments it has. So the first thing we're going to do is we're going to create a new temporary array. And it's not really, it's an object, it's an array, it's going to be an array of objects, but because it has an X and a Y. I'm going to create a variable. Now, okay, let's look at how this is going to work first. So this is our snake, or the array for our snake. It represents the segments of the snake. Let's say that this is the first segment, this is the second segment, and then so on, 3, 4, 5, 6, 7, 8. Each one of these segments has an X and a Y value that tells it where it is in the map. Okay? What we're going to do is we're going to make an exact copy of this array. And then what we're going to do is we're going to loop through this one in the normal order. So we're going to loop through this one starting at 1, and then we're going to do 2, and then 3, and then 4. But with this one here, what we're going to do is we're going to start with the last position and work the opposite direction. And what we're going to do is we're going to make it so that the head of the snake is going to get changed with the tail of this array. So the head is going to move here. This body segment here is going to change with this spot. This one's going to change with this spot, and etc., etc. So all these segments are going to get reversed, so that way the head is now going to be over here and the tail is going to be here. So I'm going to create a variable called m, and this is just going to, it's just a temporary counting variable that's going to store how many elements does our snake have, or how many body segments does our snake have. So each snake we pass into it, it's going to count however many elements it has. And the amount of elements is snake array dot length. Next thing we're going to do is we're going to loop that number of times, and this is where we're going to copy the snake's array into the temporary array. So we're going to loop this snake array dot length times. And inside of here, we're going to take temp array, and we're going to set it to equal a new object that represents the same thing. So it has an x. The x is going to equal this snake, this dot snake array, and we're going to be looking at the current index. So it begins with number 1, then number 2, number 3, number 4, dot x. So the temporary array, the first element in it, I need to put this as, needs also to be an index because it's an array of objects. So the first element of this temporary array equals the same as the first element in our snake's array. That's for the x. Now we need the y colon, and it's going to equal this dot snake array a index dot y. Okay, so this is going to accomplish duplicating making a temporary duplicate array, and then what we're going to do with that is, once again, we're going to loop over the number of elements of our snake. Snake array dot length. And inside of here is where all the magic happens. So like I said before, we're going to take the head of our real snake, and we're going to put it into the tail of the temporary fake snake. So let's see, how do I do this? I'm going to say this dot snake array a index. So we're going to work forward through our snake array, but backwards through our temporary array. So this dot snake array a index dot I'm trying to think if I can just duplicate the array itself. You know, I probably could copy it as an object, but just in case, you know what, I'm going to do x and y's. So I'm going to say that this dot x, so I'm going to say that the head of the snake right now, its x position is going to equal the tail of our temporary array. And we're not going to be using the index because this time we're going to be moving backwards, and since we have this m variable representing the last element in our temporary snake, we're going to use that. So we're going to say m. So if our snake had 10 segments, we're going to take the first segment and we're going to replace it with the last and put it into the last segment of this one. or copy what was in the last from that. So if the tail was in x, x equals 1. If the tail was there, then the head is now going to equal. So if the head used to equal 10, we're going to take that and change it to being whatever this guy's tail was. So our head now equals 1. I'm not doing a very good job explaining that. Okay, well, and then we'll do the same thing with the y position. So our snake's head is going to equal the same position as the temporary array's tail. And then once that's done, we're going to take m and we're going to minus 1 off of it. So to begin with, m, if our snake had 10 segments, m equals 10. So the head of the snake moves to the last, and then minus, so then we're going to be looking at the second segment of our snake equals the second last element of the temporary array, and then the third element of our snake equals the third to last, and then so on and so forth. And then when we're done that, because our snake has changed directions, we're going to say that it's no longer stuck. I mean, it might actually be stuck, but we're going to say it's not stuck. And we're going to reset our temporary array. Okay. All right, I think we're good. So let's see if we can create a snake that doesn't get stuck. Well, I mean, it's eventually going to get stuck if it blocks itself in, but okay, it's stuck. Now it changed directions. Come on, coil in on yourself. That's okay. It's going to coil in on itself, and then it changes direction. Okay, so that works. Everything works so far. So there was a little bug. I don't know what it was, where a certain cell wasn't. It was changing. I don't really know what that was. So I'll have a quick look over the code to see. What I think might have happened is that it went to add a new segment or something. I don't know. There was one square that was acting weird. So I want to look at the grow to make sure that it's updating the way that I expect it to. You know what it could have been? Because the way I have it set up is using hotkeys to add new snakes and to grow, specifically to grow the snake. What could happen is if I'm adding a snake at the same moment that a snake is trying to move into a cell, it can actually create this conflict where it's doing things that it's not supposed to do. So the way that I should really do this is have this set up to say that I'm adding to a queue. So I could say, let's actually do that. Let's do that. Let's see how we can do that. I'm going to call this a variable called queue, and I'm going to say it equals 0. In the game loop, somewhere in here, it doesn't really matter where, but somewhere in here, I'm going to say if q equals 1, then what I want to do is I want to call the grow method. So I'm gonna do it on every snake, so I'm gonna loop the number of snakes. And we're going to take each of those snakes and we're going to pass it to the grow method. Right? And now in numberpad 2, instead of me doing this manually, we're going to instead change the value of Q to equal 1. And then up in here, after it's done the Q equals 1, we'll reset that back to 0. So it only does this once. So this is the way that I should have done it to begin with, so that way we don't have that conflict where I'm adding it outside of the game loop. And it would be very hard for us to test to see if that's actually true, or if it's actually doing, if that was the issue. I think that's the issue. I'm pretty sure that that was the issue. And I was aware that that could have been an issue. But anyways, let's get some long snakes. So let's resize this. Do it 1200 by 600. We'll add a couple of snakes and let them grow a little bit and then let them go. See what they do. But okay, so for you, if you wanted to change this into a snake game, what kind of things do you think that you would need to do? So first of all, you wouldn't have the snake changing its direction on its own, right? You would be controlling it. But rather than, this snake is supposed to be automated and everything like that, so we give it 4 choices on the directions that it can choose. But for you, if you're controlling it, all you really need to do is tell the snake if it's always moving in the current direction that you have set. Well, I mean, you will give it 4 directions, but the way you change directions is, you're not going to give it 4 things. You're going to give it inputs, and those inputs, all you need to do is give it a left or a right. So for example, if your snake is currently moving forward, or to the right, because it's always moving forward, but if it's moving to the right, you could set it so that way if you want to change directions, all you would have to do is press the left or right arrow. So if you press the left arrow, you would be subtracting from its position or its direction. So let's say it's moving in direction 2, and if I press the left arrow, I'm going to subtract 1 from my direction. So my direction will now be 1, so I'll be moving up. If I use the right arrow, I'm going to add to my direction, so now I'll be moving down. So all I have to do is use the left and right arrow, and I can change, either add 1 to its direction or subtract 1 from its direction, which would change the number that it has. And then all I'd have to do is limit the amount of numbers. So if we're, for example, if we're going to be adding or subtracting numbers, we want to limit it between 0 and 4. So we'll say if I press right, so let's say if my direction was 4, which is left, and I press, which number am I looking for? If I press, which one is adding? Adding is right. If I press right, which would be to add to my direction, because I'm already going in the 4th direction, there is no 5th direction, I would have to reset the direction, the number for my change back to 0. So if I'm traveling in the 4th direction and I press in the direction that adds to my direction, I'll reset it back to 0, so that way I can keep going in a circle. If you code it out, you'll understand what I mean. The other thing that you would need to do is also figure out a way of adding food. So how would you go about adding food? Well, food is something that you can just simply add into the snake object. When you start a new game, you can have it generate a piece of food, and then you can have your snake, not only when your snake is traveling around, not only check to see what is in front of it, but also perhaps, no, I guess you could do, so you know how we have our snake right now, where each time it runs through the game loop, it goes through this move method, and the move method says if the direction is 1, look at the cell above me and see if it has a value of 0. If it does have a value of 0, go ahead and move into it. What we can do if we add food is we could add food as having a value in our map as a value of 3. So what we could say is, if we have a value of, we could test to see, is the cell in front of us have a value of 0 or does it have a value of 3? If it has either of those, go ahead and move into it. If it had a value of 3, now we can call up our grow method, which automatically grows our snake. And then we can reset the food. Right? Very easy stuff, but I'll leave those kind of challenges to you. We have the core elements of creating the snake game done. Where in your game, you would want that if it collides with itself, it doesn't change directions, it dies, resets the position, and starts the game over again with a brand new snake that has X amount of segments, and it grows each time you pick up food, and it dies and resets each time you collide with yourself. You can also set it up so that way if it hits the border, it teleports to the other side, which is things that we did in previous tutorials. So I didn't bother including those in this. But that's it for this one. I hope you had fun with it, and if you have a topic that you'd like to see covered in the next tutorial, go ahead, leave a comment down below, and maybe if I want to, I will do it. But if you don't say anything, well, definitely not going to be doing what you want. Right? Alright, anyways, have a good day. Peace.